Thank you for coming to the session. I know it's afternoon. I will try to make sure I don't let you fall asleep. We are going to have an exciting set of product demos. We have a couple of our customers sharing their stories, how they're using the platform. And the whole goal here is to go ahead and today morning in the keynote, did you get a chance to see the Smart Analytics demo? Was it good? Great. So the key thing is we want to take that whole theme about smart analytics, give you more context of what other product announcements we are making, what are we launching, and give you all the details that you need. But before that, let's talk about what's changing in the world, right? If you think about industries across the board are changing. If you think about automotive industry, historically 10, 15, 20 years back when you looked at automotive industry, it was a very different industry. Now with organizations like Cruise Automation, they're collecting real-time information from all of their vehicles, doing self-driving cars, making real-time decisions at massive scale. And so the whole ability to go ahead and create these large amounts of data and make decisions is super important in organizations. The second key thing is, another great example is AirAsia. If you look at democratizing data insights within organization is becoming more and more critical. So AirAsia last year at Next, they were here with me at this session, and they were sharing, they've saved like roughly 5 to 10% on their operational costs. In an airline, that's a pretty large number. And this was possible only because they were able to take all the data and insights within the organization, make it available for all of their users who are actually doing different kind of activities within the organization. So it's very critical not just to have infrastructure that can scale to do massive amounts of queries, but also to go ahead and make those insights available to everybody within the organization. And then there's other aspect to it. A lot of different industries, a lot of different customers, like Broad Institute, which was founded by MIT, Harvard, and Harvard hospitals. They're basically producing like 12 terabytes of data per day, and then leveraging the cloud computing infrastructure to do genome sequencing every 12 minutes. And so it's interesting to see how organizations across different industries are actually using cloud computing, especially our data analytics platform, to take massive amounts of data, derive insights from them, and make decisions at every point. We are seeing momentum across all different industry verticals, all different regions with the platform. Few key interesting facts I wanted to share with you today. One, with BigQuery, we now have more than exabyte amount of data managed by BigQuery for our customers. We have our largest customer now has more than 250 petabytes of data in a single data warehouse. And we had last year roughly 300% growth in data analyzed on the platform. So it's fascinating to see all this growth, organizations across the world leveraging the platform, leveraging the insights that they can gather from Google Cloud. So let me talk a bit about what's our philosophy around our investments in analytics platform, right? Our main goal is, we have this theme called radical simplicity. Like our goal is to make sure deriving insights from data needs to be super simple, get to a point where anybody within an organization should be able to do that. And how do we do that? How do we make it happen? One, the most important thing is investing in serverless. You should be able to bring any data, do not have to worry about infrastructure, put it into Google Cloud, and start analyzing it. The second is you're providing comprehensive solution that provides the end-to-end life cycle of your data management. Then embedding ML, not just using ML to improve our products, but also making sure ML is available to everybody within the organization. And then we are a firm believer in open cloud. We are a firm believer in making different open source components available to you to run at scale within our environment. And finally, all the enterprise capabilities that you all expect us to have within the platform is super important. So quick visual, the key thing about serverless data platform is one, where in traditional platforms, you would have to go ahead and spend time in figuring out what's your capacity requirement, how many servers are you going to need, what's the provisioning, what's the monitoring. There's so much stuff goes into that. But our key thing is you shouldn't have to worry about all that. That's all managed by Google. We take care of that. You just bring as much data that you need to bring, start analyzing it from there. And then from a platform perspective, I know there are a lot of logos here. I'm not going to go in depth of every one of them. But from an end-to-end lifecycle perspective, we have services that allow you to ingest data, and that could be at real-time streaming at scale, like PubSub. You can do millions or billions of events per second collection. There's services for transferring data from on-premises, different SaaS applications. We have service for IoT data coming in. So all the ingestion services are available to you. Then for all the real-time and batch processing, we have data flow, which is our streaming like engine capability. It allows you to do batch and streaming with a single API. With data proc, you can do managed Hadoop and Spark environments. Data prep allows your data analysts to go ahead and do data wrangling. All of these are available to you. And then in data warehousing, you have BigQuery. You can use cloud storage for storing massive amounts of unstructured data. And then on advanced analytics side, you have our cloud AI services. So that's the whole portfolio. We have a whole set of things. In addition to that, we have Cloud Composer, managed Airflow for you to go ahead and do workflow orchestration. And then we are announcing 2 new services. You heard about them today around Cloud Fusion. We'll talk more about that. And then Catalog. So that completes the whole portfolio that we have. And then with that, let me share a few more things on different scenarios. So when we talk to customers, there are 3 main scenarios that our customers leverage the platform for. And Thomas earlier today mentioned these, and I will try to take them into the next step and give you more details. But one is modernizing data warehouses so that you can go ahead and make it broader than just data warehousing for reporting and dashboarding. It's more about intelligent decision-making, predictions, and stuff like that. So we'll talk more about that. The second is running large-scale Hadoop clusters on premises that customers are running, moving that into cloud to get much better TCO, but also get scalability that cloud can provide. And the third is streaming analytics. I think by 2025, more than 25% of the data that's generated will be in streaming form. And as the industries are changing, you will need capabilities that can collect this streaming data, make real-time decisions on them in the application that you are in and all that. So that is super critical, and that's what customers are using. Other than that, we heard a lot from our customers about breaking the data silos, making it easy to get data into the platform, and then also protecting and governing the data. So we have those solutions available. So let's talk about the first thing. Earlier today, you saw a demo of Fusion. So Cloud Fusion basically is our fully managed code-free data integration service. The whole idea is we want to make sure that bringing data to GCP is super easy for our customers. Data Fusion is actually based on an open source project called CDAP. And it gives you a visual tool to go ahead and drag drop, pick from hundreds of connectors that we have already got for you for on-prem systems, different applications and all. And then you can go ahead and transform the data that's coming in, and you can publish it into any one of the data stores that we have. Could be BigQuery, could be Cloud SQL, could be any one of the other data stores that's available. The key aspect to this is the goal here is just simplifying migration of your data to cloud, transforming it as it's coming in, and making sure you have a single place to manage all your data pipelines. And then finally, it provides you ability to go ahead and do visual transformations. As you're coming in, you can go ahead and track lineage about the data that's coming in and provide data quality on top of the data. So this is one of our big releases for this next. It's available in beta, so you can go ahead and leverage it. You saw some of the demos earlier today. There are 2 other things that we have in the same realm. We basically we have in BigQuery, if you have used BigQuery, it has connectors that were available from our first-party services, like AdWords, like DoubleClick, and all of that, to make it easy for customers to bring data in from these applications and then put it into BigQuery, analyze it. We have extended that to our partner ecosystem. And so now I'm happy to announce we have more than, I think, 135 connectors across different applications, starting from like Salesforce, Marketo, Adobe Analytics, Facebook Analytics, Workday, all the different SaaS applications is now available, and customers can use that in your BigQuery environments. You all can start using that. And the third thing is, we know there's a big challenge on migrating the traditional data warehouses that are running on premises, let's say like Teradata, or if you're using Redshift, we have tooling now available to easily migrate those to BigQuery. So that's the key thing, that we're providing all this tooling to make it easy to bring data into GCP so that you can start leveraging the other capabilities that we already have.
Customers want us to be able to help them understand their business better. They don't just want us to do their banking. Our employees' expectations are changing as well. They'd like us to provide them with relevant data and insights so that they can make smart decisions in a timely manner. And so to do that, we need to look at digital transformation, and a key part of that digital transformation is data.
Got it. So can you share some use cases with BigQuery or other things that you're using so that we can get more insights into what you're doing?
Yeah, absolutely. Ivan, do you want to talk about some of the BigQuery uses?
Yeah, of course. So BigQuery has been one of the key tools that our data scientists are using on a daily basis. And it actually effectively helped us a lot in terms of the scalabilities and handling those heavy computational queries on top of the different data sets. So I will give you a real story from our team. So some of our data scientists are working on using those customer transaction data to build those aggregated and de-identified insights for our institutional level clients for them to understand their customers better. So those analysis including what's your loyal customer look like, where they are living, and who are lapsing from your business. So we are analyzing billions of transactions of the data, and back to that time, it was around 17 terabytes for a single table for us to run, and it took literally 5 days to extract the data and get the insights from the data set, and which is actually quite costly for us to deliver our insights to our clients, and also limit our data science to continuously develop new insights, adding new innovations to the data set. And by moving that whole pipeline to the BigQuery, we successfully reduce the times from 5 days to 20 seconds to get the insights, which is a big achievement for us, and not only enhancing the efficiency for our data scientists, but also allow us to start rethinking the data science process in the organization. So our data scientists start to meet our clients directly rather than over-optimizing those queries sitting at the back end. And they are bringing their insights to the clients, taking the direct feedback from our clients to together conduct the customer-led design workshop to get those customized insights requirements to support our clients better. So the reason we are taking customized insights is we have the confidence that BigQuery can help us to handle those heavy computation backend. And we managed to work with airline industries to help them analyzing their customers' shopping behavior before and after flying, so they can use those insights to optimize their campaign effectiveness. Also, we've been working with a few retail industry companies in Australia to help them to identify which location is the best for them to open a new store. So such kind of customized analysis help us to position ourselves not only a service provider, but also a strategic partner from the data and analytics side perspective for our clients. And currently, we have streams of data scientists working on bringing more data like payments, and supply chain, and credit rating data on the GCP, and to combining those different data sets together, commingling those data sets to unlock the value of the data sets in the bank.
I think that's awesome. I just heard 5 days roughly to few seconds is where you were able to drop it. That's the power of at scale what you can do with data processing and analytics, and I think super interesting to hear. Can you share more about Cloud Composer usage, how you're using Composer for orchestration and all?
Yeah, of course. So team have been exploring different orchestration tools, and we've been using Composer since it was in alpha version. And it's a great tool for teams to keep going, and our data scientists are loving it because it's Python-based, and it's very easy to manage your dependency and the multi-layer of the data pipelines. And we've currently got daily and weekly data pipelines running on the composer to generate hundreds of features and terabytes of data, multi-terabytes of data. However, with the growing of the teams and the complex of the data pipeline, we sort of meeting the challenge like running multi-tenancies on Composer. And we've been very excited to hear more announcements from Composer side this time.
That's great. We'll share some more today. So Keith, can you share more on how did you make the decision to go to GCP, and what should everybody here, especially in the industries like yours, think about as they move to cloud, making that decision?
Absolutely. So I think when looking at moving to a cloud provider, one of our key requirements was we needed a provider to help us get the most out of our data. And so the core data capability is very important. Services on top of data, AI services, ML services, and partnering with someone who has those services also absolutely critical. But also, data doesn't live in a vacuum, and where the data is where application delivery starts to converge to. And so when looking at GCP and Google, we found a provider that has those AI and ML services, also has the application delivery components. And so we're also very heavy users of GKE, Cloud SQL, and a number of other components, as well as then the underlying data capability. And so I think as an ecosystem, that's great. As a financial services organization, there are a whole other suite of considerations that then need to be overlaid on an implementation. And so as a heavily regulated industry, it's very important that when implementing a cloud environment, it's not only the awesome technology that's there, it's balanced with great controls that can meet the expectations of your regulators, that can ensure that you hit those privacy expectations, again, of regulators, but also of your customers. And I think as then a final point, an interesting piece around the cloud implementation journey is once you're there, things become a lot faster in terms of your ability to deliver on them, but it can then shine a bit of a spotlight on yourself internally as an organization and your processes and his ability to actually internalize and deliver on that change.
Got it. Good. Thank you. Thanks a lot for sharing.
Thank you very much.
Thanks, Keith. Thanks, Ivan. So it's very interesting, as we have seen in the last couple of years, how different industries have been starting to adopt cloud, starting to use some of our analytics capabilities to go ahead and leverage it for different scenarios. With that, let me share a few things around what's coming new with BigQuery in this conference. What are the different things we are announcing? One is we had a goal last year to go ahead and launch BigQuery everywhere. We have been steadily increasing our footprint globally. This is super critical as organizations want to keep their data in specific geographical locations. So we've launched like around 12 regions in last 1 year, and we'll continue the momentum going forward, make sure we are available in every region wherever Google data centers exist. So the work is not done. We'll continuously do that, but we are already in all of these different regions. We should be in your region wherever you are now. The second big thing that we are announcing today is basically BigQuery supports 2 different pricing models. It has on-demand model where you can go ahead and per query pay for whatever data you're accessing. The second model is we have a flat rate model, which gives you price predictability, and you can go ahead and buy out like X number of slots for the whole month, and then you can go ahead and use that. What we are announcing today is 2 things. In Alpha, we will have our reservations API, which will give you 2 capabilities. One, you will be able to go online, and then if you're registered for Alpha, you can start buying slots directly, which means you can go ahead and say, I want 2,000 slots, but we are also reducing the entry on that, and we are making a 500 slot BigQuery flat rate available, which should reduce the cost of entry if you want to get started at a lower level. So that's one. The second thing it allows you to do is you can quickly and easily manage resources. So let's say you have 2,000 slots, you want to distribute them into 4 different teams and say, hey, everybody gets 500 each, so that you don't go ahead and have different kinds of queries can have different priorities and stuff like that. So you can go ahead and do that that way. But we always make sure that you have access to all of those open unused slots available for everybody. So the key thing is the compute resources that you have is always available. You can use them, but you can allocate them across your organization very easily. This has been one of the asks from our customers for quite a few time now. So this is going to be available. The second thing that is available earlier, in a couple of months back, we announced storage API. So there are a lot of organizations who are putting all of their data in BigQuery. BigQuery storage is their structured storage layer, like for all of their data in the organization. And SQL is a great language for a lot of things, but not for all things. And so we have a lot of customers who wanted to use Spark or Hadoop on top of the same data that we have. Why do you want to have the same data copied in GCS and BigQuery and all the different storage layers so that you can process it? So we basically have a high-speed storage API available. With this, what happens is your BigQuery, that's the data that's stored in BigQuery, is now available from any of your Spark or Hadoop workloads. You can use data flow for batch jobs from BigQuery if you want to. You can go ahead and use the ML engine, ODBC drivers. All of them will be able to directly leverage the same storage layer at high speed, and you'll be able to go ahead and do all these workloads, different types of workloads on the data in BigQuery. So this just expands what you can do. The third thing that we have coming in BigQuery is earlier last year, I think in July, we announced beta for BigQuery ML. So we will have BigQuery ML going to GA in a few weeks from now. Along with that, we are also, based on the demand that we're getting, we have k-means clustering available. So you want to do segmentation, customer segmentation, those kind of scenarios, you'll be able to do that very easily with like just a couple of lines of SQL code. You can do matrix factorization, so recommender systems, you can go ahead and do that. And then you can import TensorFlow models directly into BigQML. So those are the three key things. The fourth key announcement that we have, and we announced this earlier in the keynote, is around BI Engine. So the whole idea of BI Engine, it's a fast, low latency analysis service. You don't have to create any kind of models or anything. You automatically, the data that's in BigQuery, it can accelerate queries on top of it. Our goal is to have all the response times in millisecond times, under a second in most cases, and then it will be available so that you can do interactive reporting and interactive dashboarding very easily across your organization at a large concurrency numbers. So that's another thing that's available. So I've talked about a lot of things here. Earlier, I also mentioned about all the 100+ SaaS application connectors. We talked about BI Engine. So let's do a quick demo. Let me call upon Michael to come and show us some of the capabilities that we're launching. Michael. You need this? Okay.
So I'm going to show you guys what it's actually like inside BigQuery to go get data from an external source and bring that in through a transfer. I'm going to try and go through pretty quickly here. Let's click the transfer button in BigQuery, and that'll take us to a view where I can see the active transfers that I have now. So I'll hit the Create Transfer button here. And we have Google's built-in transfers down here. I can transfer from Google Play, Google Ads, sources like that. But now I can click Explore Data Sources there. And just like Sudhir said, here we have a long list. We have more than 100 external data sources built by our providers that show up in this list. So for example, here is an Adobe Analytics connector, highly requested source from us. This is made by Supermetrics, one of our close partners. And we can see details about this connector. I can also enroll in it, or I can search for others on the marketplace. Another example, Facebook connectors. So we have some Facebook ads data here that you can see. I can search for Salesforce as well. And when I search there, top result here is a Salesforce connector built by Fivetran, another one of our really great partners. And I can enroll in this connector right on the marketplace and choose the project that I want to enroll in. I've already enrolled for this project. And so because I did that, it's going to show up for me now automatically on my drop-down list right there. So I hit Salesforce by Fivetran, and then I can enter the name of the connector of the transfer that I want. And I can choose the schedule that's right for me. We can go weekly, or in this case, a daily schedule. And I'll select the destination data set inside BigQuery that I want that to go to, and then hit Connect Source. And right here, I get a warning. This is asking me permission for that connector to write data into the BigQuery data set that I selected. So I'll hit accept, and then up comes this pop-up from Fivetran where I can authorize the connector that I'm interested in. So normally this would ask me for my Salesforce password. I've already done that, though. So when I click Save, this is going to create the connection for me and take me back to the transfers page where I can complete my settings for the transfer. I can also choose to get notifications if I want to in case the transfer fails. So let's click Save. And that's going to configure the transfer for me. And there, you can see it. The transfer run is now pending. So that's really all that I needed to do. That's how easy it is to go all the way from choosing one of 100+ sources, getting that into a transfer so that that goes right into your BigQuery data set. That's really all you need to do. This particular transfer takes about 7 minutes. So I have a data set already set up where you can see what it looks like once we're actually inside BigQuery. And let me just show you what it looks like. Here's that Salesforce data. We can preview the leads table. There's city data, data on the company in this case for each of these rows. We could go and query that, join it with other data, and integrate it with other information inside BigQuery. But now I'm going to show you the BI engine feature with this data. So like Sudhir mentioned, with this BI engine, we have the capability to run really fast sub-second latency queries, and that's because it's running from memory, from RAM inside GCP. So I can go ahead, create a reservation, and decide on the capacity that I want with BI engine. And then once I've done that, what can I do with it? Well, here's a great example. This is a Data Studio dashboard. It's running off BigQuery on BI engine. And as I'm clicking around here, let's see, filtering down to nurturing and new leads, for example. Maybe I want to slice and dice this by Houston and Dallas. And it's reacting really fast because it's using BI engine. So please try out BI engine today. It's in beta. And check out the external data sources on the marketplace. Thank you.
Thanks, Michael. I think the key value we can get by connecting all of these like different types of applications that are there, like organizations are using various different types of applications now, bringing all that data together, having analytics across all of them, and deriving insights is going to be very interesting for organizations, I think. And making it easy is one of our key goals. Other than that, there are a lot more other things that we are also working on, we are announcing. I won't go in depth of each one of them, but here's just some additional information. Like we will, later this year, we will have ability to go ahead and do federated queries on top of Parquet, ORC files directly on GCS. You'll be able to do federation across like Cloud SQL, which can be another data source for queries from within BigQuery. So that's there. Other than that, there is a good economic advantage report that was created by ESG group. You should take a look at it. If you're moving to cloud, especially with BigQuery, there's massive amounts of savings that you can get from a total cost of ownership perspective. Let's switch gears, talk about the second key scenario, running large-scale Hadoop and Spark workloads on GCP. One of the key things from a value proposition that we have is we let you go ahead and pick any of the open source projects that you want to run through Dataproc through Composer, that technologies that we have. For example, we have been continuously adding more and more projects. Now you can go ahead and leverage Presto. You can go ahead and already you could do Hadoop Spark, various different projects underneath it. It's secure. We go ahead and do the management of it. We can launch the clusters. We can shut down the clusters automatically and all. If you really look at the value proposition on this, I won't go into depth of each one of these points. The key thing is, if you are on-prem or you are managing it by yourself on Compute Engine versus using a managed service, the green is what you will have to do, and blue is what we take care of. So the key thing is just focus on the last column and see. You just have to manage your code, write the code, and deploy, and we take care of the cluster management and everything. That's the biggest value proposition for the cloud, especially with ephemeral clusters, you can do massive amounts of saving, so you don't have to have static clusters running throughout the day at scale for you. With that, let me call upon Jonathan and Raris from Booking.com to share more of what they are doing. Hi, Jonathan. So why don't you introduce yourself, tell us more about Booking.com.
Sure, I'm Raresh Mirika, I'm a principal developer at Booking.com. I work on enabling cloud technology for Booking.com and opening that up to Booking. Booking is the largest online travel agent in the world. We employ over 17,000 people, and we have offices in over 120 countries. So we, of course, work with a lot of data as well. I'm joined by Jonathan.
I'm John. I'm a data scientist working in data quality and Booking, so I care quite a lot about all the products we're putting together here.
Got it. So what were the key challenges, Raris, in Booking.com before you started migration to cloud?
Sure. So at Booking, we run quite a large installation of Hadoop, and on that, the workloads are mostly Hive and Spark workloads, both production workloads and human interactive. We have over 1,000 daily users over these clusters. So of course, because they like to all work together, there's a lot of contention for resources over these clusters. So that was a huge challenge for us, and that was an opportunity for us to use cloud and give the data scientists, especially for the more data-intensive workloads, give them personalized capacities, so basically dedicated clusters per user. And that was our proof of concept work that we started late 2017. That was very successful with our data scientists, and that was the business case for later on triggering a big data migration to cloud.
So that means every data scientist can have their own cluster that can spin up, and then they can work on that. Is that?
Yes, that is correct.
About it?
The default is a multi-tenant large cluster where they contend for resources, but they have the option to basically elevate that to a dedicated cluster for themselves, where the data scientist decides to a certain limit the size of the capacity that he needs.
Got it. That's interesting, because that's one of the benefits of moving these things to cloud and having that scenarios where you can have static clusters but also burst into for specific workloads and all. That's really good.
Yeah,
can you share about, I know our teams have worked together on interesting challenges you had and how we have incorporated some of them in the product portfolio. So can you talk about?
Yes, so aside from the challenges of moving the data to cloud and then integrating the data, making these clusters appear with the data on and making them available for the data scientists, the first thing that the data scientists asked for was for the toolbox, their toolbox to be there, same as on-prem, the same libraries, the same integrations with on-prem technologies and so on. So this required customization of data procs, installation of libraries, tools, etc. We found out pretty quickly that the time to spin up such clusters went up quite high, and that was impacting the user experience. So our ask towards your team was to make it possible for us to create customized images for Dataproc, which in collaboration with Google, we managed to get now to GA.
Yeah.
So that is what we are using.
No, that's great. I think if we always learn from our customers, it was a great scenario. We were able to go ahead and put that in quickly so that everybody can benefit. So Jonathan, why don't you share more about what you have been up to with the whole set of technologies?
I'd love to. So working with our Google counterparts, we started an exploration saying, well, now that we are in cloud, there are some tools that are available to us, like BigQuery and BigQuery ML, that we don't have on-premise. So let's see if we can use this for a case close to my heart. Can we surface some data quality issues that would be very difficult to do otherwise? So the scenario we chose to explore is very booking in nature. So we, of course, serve many properties on the website. You can find them. Each property has many room types. That room type might represent many rooms. But each of those room types is quite particular. They're scale millions of properties, so scale tens of millions of room types. And maybe most particular for a visitor is that those room types have lots and lots of facilities or potential facilities, something like 176 of these. So the scenario would be a customer visits the website. Maybe they have a particular facility in mind that they'd really like to make sure is there, a bathroom, a TV, who knows? They can filter for this. Well, that's really helpful from our side. However, we then need to make sure that that data is correct. How could this go wrong? Well, if you are forgetting to list this as a property manager or owner, you can lose customers by way of the filter. And go the other way, if you accidentally say that you have it, well, then you might be misrepresenting yourself accidentally, and then the customer experience is quite odd when they arrive and the bathroom isn't there, say. Okay, this is not so good. I don't know about your trip, yeah? But, so how do we fix these potential things? They also might tell us something about ourselves. Maybe we can ask better questions of the property owners. We can learn things about however we're putting this in a form that makes it so that certain repeated mistakes we can eliminate in a certain way. So this is certainly an added value for Booking if we can get this right. We're the intermediary. Okay. So again, I mentioned the data. It's very wide. It's reasonably long, tens of millions of rows, and quite wide. It's very Boolean. So it's yes or no to having a facility, but 176 of these. It's quite a lot. So we wanted to attack this using something in BigQuery ML. In particular, we're going to end up using k-means clustering. Now, why do we want to try that perspective? Well, we could attack it with rules. We could say, we know for sure that if you have pay-per-view channels, you better have a TV to watch them on, right? That's pretty reasonable. However, 176 lends itself to lots and lots of subsets of rules. It's very difficult to manage and upkeep because, well, you could be certainly adding lots more facilities in the future. So maybe all kinds of HoloLens or something like this is available in your room. So it would be very difficult to manage by hand. Let's see if we can surface these by throwing math at this problem, and especially in a quick and iterable way via BigQuery ML and SQL. So we have one premise, one assumption backing our project here, which is we assume most of the data is pretty healthy. It's pretty representative of truth. If that's true, then we hope that similar things will end up next to each other in such a clustering, and oddities will stick out. Odd things we'll be able to find. So with this assumption, I think it's a pretty good one. We know our data relatively well, and it's not our first time looking at this kind of thing, so we're hoping math will find the ones we haven't caught yet. Okay, so k-means clustering. There was a very nice talk earlier today. We gave a longer version of this. I hope you'll visit it on YouTube. But if we throw k-means clustering at this, we have just a few lines of code to build several different versions of the model. We only have to tune maybe one parameter, and we can very quickly see what comes out. Let's visualize some of those. Well, actually, sorry, let me take a step back. What would clustering look like? This is 2 dimensions, and of course we have 176. Remember, our goal is to find the things in the triangles, the ones that really stand out. If we can cluster well, the ones that are very far from their centroid, their middle, are maybe the ones where something is going odd. So this is visually what we're aiming for. Okay, here's in Data Studio, very convenient that we can look at this through the GCP pipeline. We have a lot going on, but if you look at the red on the right, this is relating both the size of clusters and also how far they are from each other. Okay, well, notice cluster 10 there is actually quite far from any other cluster. Well, that tells us something. Maybe he's odd. That's one of the ways a cluster could be odd. It could be very far from others. It turns out cluster 10 is very weird for another reason. If you look at the green there, this is the distribution of distances within the cluster. So for each cluster, if you are at 0, that means you're at the centroid. And if you're at the top, that means you're as far away from the centroid as anything in that cluster. Now, I care about cluster 10 again because, well, the farthest points are the farthest of any from their centroid. So we probably should look there first. It gives us an indication of where we could peek. So let's take a look at a few examples from, okay, cluster 10. If we drill in, what do we see here? Well, let's look at the things that this item has. I've drilled in. I'm looking at exactly one item. The blue bars there represent something about the whole cluster, cluster 10. How common is each one of those room facilities which are on the bottom? So let's take an example of, say, toilet. The red bar says, that's available in my outlier. It's also very commonly available in the cluster in total. I see toilet, I see shower, I see body soap, I see free toiletries. These are all very good things. Where would you put them? Probably in a bathroom, which is not available here. The outlier does not have a bathroom listed anyway. Maybe it does have one, I don't know. And free toilet paper. So maybe it's BYO toilet paper, I'm not sure. Maybe you filtered for that yourself, maybe that's something you want. But for my trip, I'd like to be sure that there's toilet paper waiting for me when I arrive. That's good to know. We should at least follow up with the property. Let's take one more example. Go a different direction. Of course, this one might have other bathroom problems, but let's see what it does have. So I see cable TV channels, I see satellite channels, but I don't see TV or flat screen TV. So I hinted at this before. You have plenty of channels to watch, but nothing to watch them on. We would definitely want to surface this for the property because they might be missing out. Anyone filtering for that thing is maybe going to miss this property, but it's probably likely that they have such a thing. So we found some really interesting stuff. I think these are things we wouldn't have found otherwise or would have had a very hard time to identify. Next step for us would be automation improvements so that we could do this on a very regular basis and not have to explore by hand the same way we did.
Got it. Thank you, Jonathan. Thanks a lot. There's some interesting use cases there. Thank you. Thanks, Fergus.
Thank you.
Yeah. So yeah, so let's continue on some of the new investments that we are announcing right now. I think we are investing in the security features of Dataproc so that Kerberos is now available. So, so you'll be able to use the same security models that you're using on-prem. You have auto-scaling capabilities, and then you also have one of the other big investments that we're doing with Composer is on Composer Flex. So it will allow you to make it completely serverless Composer capability. And then one of the other things is we just announced our partnership with Qbol. A lot of enterprise organizations are using Qbol for their Hadoop and Spark workloads, and their whole unified experience with the workbench, with notebooks and dashboards is super valuable for enterprises. Now they are available on GCP, so you will be able to use them. They have great enterprise security features, controls and governance, as well as seamless workload migration. So if you're using Qbol today, you'll be able to continue using that on GCP from your on-prem. The next key thing that we have is, as I said, 25% of the data will be generated in 2025 in streaming form. And we have great capabilities on the platform for streaming, starting from ingestion with PubSub, transform, and analyze across the board. And then you can also do that with our open source technologies or partners that's available. So with that, one of the key announcements that we have today is Dataflow SQL. So the whole idea is a lot of organizations use Dataflow from different platforms, like you can write Java code for Beam and all that and do it. But SQL is a good interface. A lot of customers like it, so we're making that available. Let's do a quick demo from Sergey on that. Welcome, Sergey. Keep it fun.
Thanks, Sudhir. So in this demo, I'm going to take a PubSub topic, I'm going to associate a schema with this topic, and I'm going to join it with a BigQuery table to do some stream enrichment. Once I have a schema topic and a enriched stream, I'm going to group it by time and insert the results into a BigQuery data warehouse. Now, the goal of this demo is to show you can calculate very quickly aggregate statistics on a stream of events. I'm going to start with BigQuery. Many BigQuery users will find it quite useful that they can now access Dataflow right from query settings. You get the choice of the Dataflow engine as the execution backend. And once you choose Dataflow engine and save the setting, you will be able to create Dataflow jobs. I actually have a SQL statement saved in my notepad just for demo purposes so that I can avoid typing it. I'll quickly explain what's going on here. I have a PubSub topic. This is not a table. This is actually a stream of events. I'm going to join it with a static table in BigQuery, allowing me to do stream enrichment. Here's my join condition. And the key portion of this SQL statement, this streaming SQL statement, is the tumbling function. This is the piece that allows you to do streaming analytics. It creates fixed 5-second windows, and you can run aggregations on top of these windows. That's exactly what's going to happen in my projection part of the SQL statement. I'm going to create statistics for sales regions, for all of the sales events in my stream, and I'm going to have a timestamp of these calculations and the sales amount. Oh, and by the way, I mentioned that we use schema. We store now the schema for PubSub in data catalog. Here's the schema of my PubSub topic. This is what enables me to run SQL on streams, having a schema. My events have very simple attributes. We have a timestamp and we have a payload, and the payload contains the person who purchased the good itself, where it was purchased, the state of purchase, and the amount. Well, great. So let's run the job. In my next screen, I just need to type in the destination table. Then initially, we support BigQuery as the destination, but we'll add more destinations in the future as well. Great. So within a second or two, I'm going to get a data flow job ID. That's the job ID. And if I click on it, I'm going to get rerouted to data flow. And once the resources have been provisioned and the SQL query gets executed and transformed into a data flow graph, I will see things in the middle of the screen. Now, I don't want to wait for the purposes of the demo, so I launched the job just like it a few minutes ago. Here's what you will see in the data flow experience. For those of you who are familiar with execution plans, that's exactly what's going on here. So Dataflow took a SQL statement. It created an execution plan for your SQL statement using the Beam framework. I have my, input flow from BigQuery. I have my input flow from PubSub. And I have a join condition in the middle. And for this particular SQL statement, we are using very efficient side input joins. Now, I also wanted to conclude the demo. I also wanted to show you that data is actually flowing through this SQL statement. So I switched back to BigQuery, and I have a select star statement here. Let me quickly run it. Here are the results, and let me rerun it again. All right, as you can see, I get my data updated every 5 seconds.
Awesome.
Thanks, Sudhir.
Thank you, Sergey. As I started earlier today when I talked about our one philosophy, which is making sure we make it really simple for doing the activities that you do today. You could have done the exact same thing in Java, written a few lines of code and made it happen. But we want to make it really easy for all the analysts to go ahead and do the similar activity on streaming data. And with this SQL-based language now, Dataflow becomes accessible to everyone in the organization that can write SQL. In addition to that, we also have FlexRS scheduling, which is flexible resource scheduling. You will be able to go ahead and for delayed data pipelines, you can save up to 40% by using preemptible VMs on our side. The main thing there is we will guarantee finishing of the jobs in any case because we mix regular VMs and preemptibles. And so you'll get a lot of savings, but guarantee that your jobs are going to get done. There are a lot of other announcements. I won't go in depth of each one of them, but you can take a look at them. From a governance perspective, one of the things, so we have different things that we already offer, right? We have the built-in encryption that is there, customer managed encryption keys. We talked about it earlier today. Access transparency, Thomas touched upon it. We also have tools for efficient governing as well as compliance with HIPAA and all the different compliance things. The key thing we are announcing today is data catalog. Data catalog is basically our fully managed and scalable metadata service, which will allow you to search for all your data assets, where they are, what are they, who has, all the different details along with that. It also allows you to go ahead and define schemas for PubSub, which is streaming data. So once you have that, you can go ahead and start using it in SQL. It's a very simple search experience. It gives you ability to go to auto tagging with DLP. Like we can run the DLP, we can mark PII data and all. And then you can also give your own business metadata that you can define. And then from there, we will be able to go ahead and define policies on top of it. So you can say anything that's PII, do not give access to these group of people or give access to only these people. So you will be able to do those kind of activities. But fundamentally, it's easy discovery of your data within your organization. We're going to solve that across all of different assets within GCP. Other than that, the most important thing is you have a lot of investments in the different tools that you may have acquired from your different organizations. We have a huge partner ecosystem that should just run as is without any problems. Like we have great partners in BI space like Tableau, like Looker. All those tools are there. Informatica, Fivetran, we showed earlier today, as well as Talent, all of these partners for ingestion and all. So we have a huge partner ecosystem for you to leverage. Other than that, Google has been identified as leader in both Forrester Waves as well as Gartner. So we are trending in the right direction. We have a lot of investment going in analytics platform generally, and then it's ready for enterprise adoption. We have a lot of customers, and would be great if you can go take a look at some of the key new capabilities, start playing with the products, and give us more feedback. Thank you.